Hi, I'm Josh. I'm 13 years old and I'm on the green team. Go green team! Now I like to play basketball a lot, and I mostly play outside. And I observe that when it's cold out, the basketball gets harder to dribble. With this observation, I came up with my hypothesis that the colder a basketball gets, the more its internal pressure will drop, and therefore making it harder to bounce. I wanted to test my hypothesis at 3 different temperatures: warm, cool, and cold. To get the basketball at the warm temperature I wanted it to be, I just put it inside my house at 68 degrees. To get it cool, I put it inside my fridge at 44 degrees Fahrenheit. And then to get it cold, I put it inside my freezer, which is at negative 15 degrees Fahrenheit. And this is how I tested my hypothesis. Once I had gotten the basketball to the right temperature, I dropped it in front of this chart, which I have set up here, and replayed the video so that I could find out exactly how high I had gotten it, and then recorded the height. And this is a sample drop that I did. This still shows how I found out exactly how high the basketball went. As you can see here, it's about 35.5 inches. To make sure I had a consistent drop, I lined up the middle finger of my left hand with the 40-inch mark on my chart. I repeated this 50 times at each different temperature. I also recorded the actual PSI of the basketball with this ball pressure gauge I have, so I could find out exactly what the internal pressure of the ball was at the different temperatures. This scatter chart shows the bounce height of all the different trials at 68 degrees Fahrenheit. This one shows the bounce height of the trials at 44 degrees Fahrenheit. This chart shows the results of all the tests I did at negative 15 degrees Fahrenheit. This graph shows the average bounce height of the 3 different temperatures. As you can see, there's a significant difference between the bounce height of each different temperature. This is a line graph comparing all the trials I did at the different temperatures against each other. This is a graph showing the actual pressure in PSI of the ball at the different temperatures. I did some research and found out why the basketball responds to temperature change like this. It is because of the ideal gas law. PV equals nRT. As you can see, if T decreases, as must PV, which is the pressure of the ball. As you can see, my results clearly showed that yes, my hypothesis was correct, and that as the temperature of a basketball goes down, as does the air pressure inside of it, and therefore also reducing its ability to bounce.